Assalamualaikum. My name is Syahrin Fandi bin Razali. Metric card number is B031710022. So today I'm to present my PSM2. My project name is IOT-based device for real-time water quality monitoring system. Okay, for problem statement for this project is the existing method to test water quality is to collect samples manually and send them to laboratory for detecting and analyzing. It wastes too much manpower, material, resource and cost. For objective, first one is to study condition of the water quality level of lakes and rivers by using real-time monitoring. Second one is to develop a device that can detect the pH, water level, turbidity and temperature of water bodies. Lastly is to provide statistical information of lakes and river water quality using smartphone application. For project scope is first one is focusing on the water bodies around Malacca. Second, device consists a single board computer and sensor data is accessed by application called Blink using smartphone. Third, focusing only on pH, water level, turbidity and temperature of the lakes and river. This is preliminary analysis. The purpose of this analysis is to find suitable sensor to be used in this project for calculate the level of the water. There are two types of sensor need to be analyzed, which is ultrasonic sensor and water level sensor. This is data reading result for these two types of sensor. There are two data reading for each sensor. For, as you can see, water level sensor result, this is fixed length, and the output is for 1 cm is 215 mm, which is like 2 cm, and 2 cm 231 mm, 3 cm 246 mm, 4 cm to 258 mm, 5 cm 272 mm. Same like first. For the second data, same like first data reading, which is not so accurate like ultrasonic sensor. As you can see, first and second data, the output is the output is accurate compared to water level sensor. Okay, this is past research comparison and proposed system. There are 5 journal. First journal is IOT-based real-time river water quality monitoring system. There are 4 type of sensor, which is pH sensor, turbidity sensor, temperature sensor, flow sensor. The microcontroller that they use is Arduino Uno. For functionality, is measure water parameter, assemble data from various sensor node, send SMS when water not match the preset standard. For second journal is called intelligent IoT-based water quality monitoring system. They use 2 type of sensor. First sensor is pH sensor and TDS sensor. They use 2 type of microcontroller unit, which is Raspberry Pi and Arduino Uno. for this functionality, for their functionality is analyzing water quality. Third journal is IOT-based water and soil quality monitoring system. They use 4 type of sensor. First sensor is pH sensor, turbidity sensor, moisture sensor, conductivity sensor. They also use 2 microcontroller, which is Raspberry Pi and Arduino Uno. The functionality is check substance is used to gauge the idea of water, and analyze the idea of the water resource. The fourth journal is the monitoring of water quality in IoT environment by Anwanda T, 2018. They use 3 type of sensor: pH sensor, turbidity sensor, temperature sensor. They use Raspberry Pi as for microcontroller. The functionality is monitor the condition of water. Sensor data can be viewed on the cloud using a special IP address. The last journal is IoT enable real-time water quality monitoring system by Gita and Gotami in 2016. They use 5 type of sensor, which is pH sensor, turbidity sensor, temperature sensor, water level sensor, conductivity sensor. They use TICC 3200 launchpad for their microcontroller. The functionality is sensor to be connected in pipe. Monitor in the proposed system are conductivity, turbidity, water level, and pH. For proposed project, I'm using 4 type of sensor, which is pH sensor, temperature sensor, turbidity sensor, and ultrasonic sensor. The microcontroller that I use is Arduino Uno. Okay, for the functionality, collecting water quality data in real time, store all data on cloud, provide a way to measure the water parameter, able to alert certain threshold pass. Okay, the difference between my project and others is, as you can see, real-time water level only my project and Gita and Gotami in 2016, but they their project doesn't have a water level alert if certain threshold pass. Okay, so methodology for this project is waterfall model. First, requirement analysis, system design, implementation, go to testing, then deployment and maintenance. Okay, user design. This is user design for first section. All the sensor give an input to microcontroller, which is Arduino Uno. Then the real-time data will be uploaded to the cloud storage using Wi-Fi module. So the third, user will get notification alert on smartphone if certain threshold were to be surpassed. Lastly, the analysis data can be retrieved by website page, and also the smartphone application, which is Blink. Okay, this is flowchart. First, start, then need to power on the Arduino Uno. Then the sensor will measure the value, pH water value, turbidity, temperature level, and water level. All the output will display on Blink application and ThinkSpeak website. ThinkSpeak website also can generate a report. There is a condition for notification alert to user. Okay, it's architecture design and complete prototype of the system. This is ESP8266 Wi-Fi module. This blue stick is pH sensor. This is a turbidity sensor. This thing is a temperature sensor. This sensor is ultrasonic sensor, and this is power bank for power to give power to this system. Okay, next this blink interface. Okay, as you can see, there are 5 widgets in this interface. First is temperature, turbidity, and pH value, water distance. This widget I add for let user know the real-time water level is. If the water level is almost full, the water level will show at top of the tank. This will go top, and if water level is low, the level will show at lower level. So this is pop-up if the okay, this is for real-time notification pop-up. So for this situation, if the water level is below 50 cm, so the noti will pop up tell that the water is too high. This is testing environment setup. This is for turbidity sensor. I'm using a mixture of soil and water for turbidity sensor, and plain water to compare the reading. This is testing environment for pH sensor. For this situation, I use 3 type of liquid solution, which is vinegar, plain water, and soapy water. Okay, next, this is testing environment for ultrasonic sensor. I'm just illustrate the environment because I don't have a big container to test the low level of water, as this sensor will measure up to 5 meter, equal to 500 cm distance. This is where we place the ultrasonic sensor of the top of the water reservoir, so they can transmit to get a reading and retrieve the data to get a reading. They will detect the water surface to get water level. Okay, this is testing kit. This testing kit is for reference and to compare the output with my sensor. To use the pH testing kit, we need at least 5 mm of liquid solution. Like previously, I used 3 types: is soapy water, vinegar, and plain water. And then add about 3 drop of this solution, then we will get the result. Before we get the result, after we add the water, this solution, the color will turn into other color to match the color in this card. For temperature testing kit is we only push the button to get temperature reading. Okay, this is pH value data collection. This is for soapy water, so the color turn to blue color. So the reading for this is 8.0 to match the color in this card. Then this is for plain water. The color turn into green. So for in this card the pH is 7. And this for vinegar, the water turn to orange color. So in this card for orange color is 5. Okay, test result analysis. Okay, for pH sensor, the actual, like previous slide, we see the 7 for plain water, for vinegar 5, soapy water 8, and my sensor get an output for plain water is 7.22, and vinegar is 4.83, soapy water 8.90. For turbidity sensor, for solution for water and soil is 0.17, and plain water 3.47. So for this result, we can see if more cloudy solution water, the less of the quantity for the reading. If more clear water, then we get higher reading. Okay, for temperature sensor, the actual for hot water is 57. This readings is collected by the testing kit. The sensor for this project get 56.7. Room temperature water is 26 instead of 26.5. Cold water 13.3. The actual is 14. Ultrasonic sensor is very accurate for water distance, like the preliminary analysis test before. Okay, other analysis is power consumption. This is Blink application. The device begin to online. In this application, in this situation, they state the online since 9:46 p.m. Which is this system is online. My Arduino is online. Then the last reading, the last device is offline is 1:06 a.m. in May 16. So the total hour of device online is 28.33 hours in one full charge of 10,000 mAh power bank. For strength and weaknesses of this project, the strength is eliminate the process of water sampling, reduce water labor and time, monitor result remotely, visualization of data, notification alert. Weaknesses is power source, which is we need a higher capacity of power bank or other source like solar power, and requires a good wireless connectivity and equipment degradation. um, okay. The project limitation, first, it maintain the quality of the data collected. The device and sensor become less accuracy over time and require a lot of resource, to which are mainly cost. Some of my sensor had a problem with their output because of cheap product. So we need a more resource to get a better product and can get a accurate result. And for future work, we can add more sensor to others can add more sensor to detect multiple parameter, and can expand to other fields such as irrigation, architecture, and marine life preservation. Okay, that's all. Thank you.